Okay, greetings, guys. I just wanted to show you off my circuit that I made. This is, of course, just an assumption of how I think that my converter works, or the EU to US or Japan, the Japanese standard converter from 210 to 110 volts. It can be used for consoles or chargers for your uh, old video cameras that are imported, because they use different standards. Of course, now many mobile and console adapters will have the option to be plugged into a US or the EU plug, but you will need to get the cheap adapter, which you can find basically at any thrift store, market, or whatever. But I think it was during the 90s, maybe even now today, for some reasons they use different types of transformers and standards, as for profiting, as just as for security reasons, or whatever it may not the reason be. Uh, and I basically use this circuit, or the converter, for my Nintendo 64 and PlayStation 2 that I got from Japan. So I already connected it. You guys probably all know how to pick components. We have the alternator, we have two AC emitters, we have of course the inductors, which represent the transformer, and this one is like a center tap, because what they do, uh, essentially, like, it's not I promised this in the last video, uh, and I forgot clearly to explain how I think this works. And I will, how do you say that? Like, re-explain it in Bosnian, because I didn't do that in previous video. But you would think that you have like 220 volts, have some, winding here, smaller winding here, and 110 we got here, and this would be an uh, isolated transformer, and that would work. In fact, that would be very, very good. But it's uh, it's more expensive way to do it, or it's just, it's not difficult, but it wouldn't pay off for the company, and it wouldn't pay off for you, because you're essentially using that for, or you're essentially using this converter for some smaller applications. If you want to create a lab for, I don't know, designing electronics or power electronic devices, then isolation transformer, I think this one's called the isolation transformer, isolation transformer, um, you would use this circuit. But my theory on how this uh, converter works is that they basically just took one part of the winding, they took the midpoint, and that would be like the line out the positive side, and they started winding back the same amount of turns. So whatever we have here is whatever we have here. And let's mark this as a D1 and mark this one as a D2. And they took, if we, for example, have, this is now connected to, of course, we have a fuse. I'll just mark it as F. One part goes to the line, and one part is the end. And of course, the fuse could also be on the other side, because fuse always needs to be on the line, and when you plug it into an outlet, it's reversible. You can plug things both ways. Like you're trying to plug in a vacuum, it can go both ways. So maybe this fuse could be on the other side, but this is not really that important at this moment. And they took neutral here, so this is the same dot neutral. And because we have 220 volts here, if we split it into half, you would get 110 volts here. It's pretty easy now, but in order to get the best efficiency, to design it ergonomically and all, it's much more complicated. And to count all in the extensive workload forces and all of that complicated stuff, it requires higher knowledge. But I think this is some kind of theory on how it works. E sad ću ponoviti ovo na bosanskom, znači ovdje imamo kao taj tip transformatora, kako mislimo da bi ovo kolo radilo. Ovo je transformator, to jest ovo kolo što ima mjesta za te neke manje ispravljače i stare Nintendo i PlayStation konzole. Zato što prije tamo negdje u 90 i 80 ili kako već, držali su svi svoje standarde, i onda valjda od 2000 ili kako već, valjda su dolazili ti zakoni, jednostavno govorili su ljudi, morate jednostavno praviti neke univerzalne adaptere. Nemamo toliko više bakre materijala. I jedna strana je skroz odcijepljena od druge. Znači šta god da imate ovdje, to nema utjecaja s ovim. I ovakvi transformatori su jako dobri za laboratorijske stanice i slično, ali mislim da su skuplji za izgradnju i, kako da to kažem, jednostavno nema smisla da koristite nešto toliko napredno ili, da kažem, te kvalitete za manje uređaje. Tako da nećete, na primjer, ne znam, ja kupiti gitaru od 100 maraka i pojačalo od 2000. Eto, primjer, lupa. Tako da, šta su oni uradili po tom nekom mom mišljenju, jeste da su taj namotaj, to jeste taj već neki postojeći dio transformatora, već kako, znači samo našli su presjek, to jeste napola, zato što čak kada mjerimo otpor na ulazu je 2 puta od onog što je na izlazu. Ajmo reći da je na izlazu otprilike 15 ohma što je bilo, negdje varira između 14 do 15, a na ulazu je oko 30, znači to je to. I uzeli su naravno ovdje zajednička je 0, ovdje faza, mislim da je fuse na kraju, eto, znači samo radi toga. To jest ne znam kako su oni to već obrtali, šta su tačno radili, ima sigurno još par nekih komponenata i svega toga, ali to je uglavnom neki kao prikaz šta su oni pokušavali da uradi ovdje. So yeah, all in all, this is how they save money on this circuit. It works, it's great, but it's not isolated, so be careful. And it's limited by watts. So I think it goes like 45 volt amperes for 1 hour. Anything above that, this will burn. Znači 45 watt ampera, sat vremena. I ako dođe kazaljka sat i 1 sekunda, planeta eksplodira. Okay, so and this is basically how the circuit works. You plug into outlet, you get the voltage out, and this is basically the load, and currently it's sitting at 25 percent of 1k, so 250 ohms is the limit. If we put 100 ohm resistor or as the load, let's say some adapter or a console has the resistance of 100 ohms, this fuse would break. And you can get the fuses by just typing in fuse, and make sure to get the animated one. For some reason the generic one didn't work, but the animated works. And when you pick it, you just need to set the value by editing properties. 1 amp, 2 amps, 0.5 amps, whatever. And you also have the resistance. We don't need this right now. Now let's start the circuit. As you can see, it works. If we go above, boop, so no voltage, no current here, no current here. And if we go back, the fuse is dead. So we can restart the circuit, and it's good now. We can increase the load's resistance. We can either decrease it by some point. Let's go to 50. So it's currently sitting at 500 ohms. We have 0.3 amps here and 0.15 amps here. So that's good. I'm not sure about the inductances, but I think that if you take in the general like resistance and you have the output current, you can get the reactive resistance. Basically you can get the L out of it and divide that L by 2, and you get inductance on one side and inductance on the other side. It's kind of difficult to explain this way, but in practical terms, I think I would find a way to do it. But you will, of course, need to cut the circuit and place ampermeter in between, or to get that clamper to measure the current. And as we can see, we have 220 volts here. And this, the output voltage is lagging, should be lagging. Let's put it up. It's lagging. Perfect. Let's move it. There we go. Let's this. Works. So it's pretty easy and straightforward. And if you need any tips and tricks, feel free to email or message me.